Number 38. Theorem number 38. Can you draw this figure? This figure illustrates again a cyclic quadrilateral, and one side of that cyclic quadrilateral has been produced like this, right? And you can see an exterior angle like when a side of a cyclic quadrilateral produced, the exterior angle so formed is equal to the interior. This is the interior angle of that exterior angle. Interior, but interior opposite this, right? Right. So the exterior angle is equal to interior opposite angle of a cyclic quadrilateral. A equals B. Okay. Shall we write down then this theorem? If one side of a cyclic quadrilateral is produced, the exterior angle so formed is equal to the interior opposite angle of the quadrilateral. Interior opposite angles of a quadrilateral. Again, I will read you. If one side of a cyclic quadrilateral is produced, one side is produced like this, the exterior angle so formed is equal to the interior opposite angle of the cyclic quadrilateral. You have to remember all these theorems very well in order to do this question. There are two questions on geometry in paper 2, part B, right? Carrying 10 marks each. So if you could do these two questions very well, then you will be able to obtain 20 marks, right? So it's very important to study these theorems very well. Regarding tangents, 39, theorem number 39 is regarding tangents. This is the theorem which define the tangent, right? We can say that this theorem is the definition of the tangent, right? You can see here OA. OA is the radius. This line touches the circle at a single point, right? Then the straight line drawn through a point, right? Through a point on a circle, right? On this point is on the circle A. So this is the straight line drawn PQ, right? PQ is the straight line drawn through a point on the circle A, right? A circle and perpendicular to the radius. That line is perpendicular to the radius, right? It passing through a point on the circle and it is perpendicular to radius as well, right? Then that line is called as the tangent and that point is called as the point of contact. This is a point. Point A is called as point of contact. So perpendicular to the radius through the point of contact then is tangent to the circle. That is a tangent to a circle. PQ is therefore a tangent. Can you write? Can you draw this figure and then write the theorem? The straight line drawn through a point on a circle and perpendicular to the radius through the point of contact is a tangent to the circle. Okay, let's move to the next theorem. Theorem number 40. Theorem number 40. Theorem number 40. Again, there is a circle and a tangent. This theorem says that this tangent and radius are perpendicular. The tangent drawn to through a point on a circle, right, is perpendicular to the radius drawn to the point of contact. This A is called as point of contact. This is a tangent. Then the tangent only the tangent passes through only one point on the circle, right? That there should be only one point of contact. Can you draw this kind of figure? There is a circle and there is an exterior point outside the circle. From an external point, you can draw two tangents. You can draw only two tangents. There are no many more than two. There are no more than two tangents. Only two tangents can be drawn. Maximum number of tangents can be drawn is two from an exterior angle to a circle. So here this says AB equal to AC. AB is the tangent. AB is the other tangent. They are equal in length. Tangents are equal in length. The second part, BOA angle. BOA angle is this angle is equal to COA angle. COA angle. And these two angles are equal. This angle and this angle and this tangent subtend two angles. This tangent subtend this angle. This tangent subtend this angle. The angles subtended by these two tangents are equal. Then third one, OAB angle. OAB is sun, right? This angle. CAO. CAO angle is this angle. So these two angles are equal, right? That means angles between the angle between two tangents is bisected by this line joining the center and the exterior point, right? The angle between two tangents is bisected by the line joining the center and the exterior point. So shall we write down this theorem? If two tangents are drawn to a circle from an external point, then the two tangents are equal in length. Two tangents are equal in length. The angle between the two tangents is bisected by the straight line joining the external point and center, and the tangents subtend equal angles at the center. Tangents subtend equal angles. This angle equal. The second point says this angle equal to this angle between two tangents are the angle between two tangents is bisected by this line joining the center and the western point. First point says tangents are equal in length. Okay, then shall we move to the theorem number 42. This is the last theorem in geometry we learn. We study here. You can see a circle, circle, and a tangent, and a chord. Tangent, this chord. If you consider this chord, the angle between the chord and the tangent here, x, is equal to the alternate segment angle y. This y is the alternate segment. This part is called as alternate segment, right, of this x angle. So x is equal to y. Another way, there is another angle between the chord and the tangent. It is p. P angle is equal to the alternate segment angle q. Yes, P angle, the angle between chord and the tangent. Tangent is this, chord is this. The angle between the tangent and the chord is equal to the alternate segment angle. Is it clear? Can we draw this figure and write aside this? And write down the theorem. The angles which a tangent to a circle make with a chord drawn from the point of contact are respectively equal to the angles in the alternate segment of the circle. The angles which a tangent, the angles which a tangent to a circle make with a chord drawn from the point of contact are respectively equal to the angles in the alternate segment of the circle. Okay, shall I move to the next slide? Shall we discuss to do this question? You have to find the magnitude of x angle. Anybody who can say the answer? Very easy question.